All right, this is Math 209, Week 1. We're dividing a polynomial by a monomial, and I think this is video 10 for the week. All right, so a couple of ways to think of division, and when you have just a monomial over a monomial, I'm going to show you a nice, easy way to think about dividing. You're going to take that 20x cubed over 4x squared, and you're going to write both of those in expanded notation. So 20x cubed is going to become 2 times 2 times 5 times x times x times x. Now, where the heck did I get that? I took 20 and I kept breaking it apart using multiplication and division until I couldn't break it apart any further. So in my mind, I did 4 times 5, but then 4 could be broken up to 2 times 2. So now I have 2 times 2 times 5, and that is my 20. And then x cubed is x times x times x, right? So there's my expanded notation for the numerator, the top number. Then the denominator is going to be 2 times 2 times x times x, all right? Because what's 4? It's 2 times 2. What's x squared? It's x times x. So there we go. All right, now 2 over 2, that's equal to 1. They cancel each other out. 2 over 2, that's equal to 1. They cancel each other out. X over x, that's 1. They cancel each other out. X over x, that's 1. They cancel each other out. So what are you left with? Well, in the denominator, you're left with 1 because everything got canceled out. In the numerator, you're left with 5x. So 5x over 1, well, that's just equal to 5x. And there's your answer. There's other ways to think of division, and I'm going to show you those in later problems on this video. So here's a perfect time for me to show you that other way to think of division, because you'll notice this time this is not a monomial on top of a monomial. You've got a binomial. So you're going to use this new method for dividing. So I'm going to write the problem down. Right? There's the problem. But we're going to write it kind of like a division problem, like when we were kids. Like this. All right? Now I'm going to say x, and remember this is x to the first power. What do I need to multiply x to the first power by in order to get x to the seventh power? Well, I need to multiply by x to the sixth power, because x to the sixth power times x to the first power gives me x to the seventh power. And just like when you were kids, like if you were dividing like 5 goes into 384, what would you do? Well, you'd say, well, 5 goes into 38. Let's see, 5 times 7 is 35. And then you would subtract, right? And then you would subtract. Well, that's what we're going to do now here. We're going to subtract. Well, x to the 7th, take away x to the 7th, that gives us nothing. They cancel each other out. And then what would we do after we subtract? Well, we bring down what's left over. So we're going to do the same thing. We're going to bring down the x to the 5th. And now we're going to say, well, what do I need to multiply by x to the first by in order to get x to the 5th? Well, I'm going to add x to the 4th. I'm going to multiply by x to the 4th, because x to the 4th times x to the 1st gives me x to the 5th. All right? And so now I can subtract those, and I get nothing because these guys kind of cancel each other out. And there is my answer. Just like when you're dividing over here, like in 4th grade, the top up here is your answer. And so here is our answer, x to the 6th plus x to the 4th. So I'm going to show you another way to think of division. Okay, so you're getting choices here. So the idea is, originally I'd said, okay, 2a to the 3rd goes into a to the 4th minus 4a to the 3rd, right? Now the idea is you're kind of messed up here, because we know we need this number to be a 1. And so you can't really get this to turn into, you can't times 2 by something to get a 1. Well, you can, it's going to be a fraction. But this kind of tells you we need to move to plan B. So plan B says, and I'm going to copy the problem, and plan B, that's my name, lingo, right, is basically it means each one of these terms up here is going to be divided by this. So you break it up. So it becomes a to the fourth over 2a to the third minus 4a to the third over 2a to the third. So you see what we did was we took each term up at the numerator and divided it by the denominator. And now we're going to do some simplifying. So you could say, well, 3 a's, these a to the thirds down there, cancel with 3 of the 4 a's in the numerator. So you're left with a over 2 as this simplified version right here. And then over here, these a third cancel with these a to the thirds. And then 4 divided by 2, that means the 2 turns into a 1 and the 4 turns into a 2. So this whole thing, this whole term turns into minus 2. And there is your answer. So again, we can do the exact same concept up here. So when you have like a trinomial divided by a monomial, you can take that thing, so it's going to be 20x to the fourth minus 4x plus 8 all over 4x, and we can separate it into 3 separate problems. So it becomes 20x to the fourth over 4x minus, then you've got 4x over 4x, plus you have 8 over 4x. So there's our, we took it and we broke it up into 3 separate problems. And now the first term right here, the 20 and the 4 becomes a 1, the 20 becomes a 5, because both 20 and 4 can be divided by 4. 20 divided by 4 is 5, 4 divided by 4 is 1. And then this x, and there's 4 x's up here, 1 x down here. So this x cancels with one of the 4 x's, leaving you with 5x to the third power. Right here, 4x over 4x, that whole thing cancels out, leaving you with 1. So that becomes minus 1. And then plus, and then what's this? Well, the a and the 4, both of those are divisible by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. So you end up with 2 over x. And there is your answer. So here we've got a same exact thing, only this time they're trying to scare you by writing the problem differently. So it's really 12a to the 7th minus 10a to the 9th plus 4a to the 3rd all over 2a to the 7th. And so we're going to separate that, 2a to the 7th over, 12a to the 7th over 2a to the 7th minus 10a to the 9th over 2a to the 7th plus 4a to the 3rd over 2a to the 7th. So we took it and we separated it into 3 separate fractions. And now what do we end up with? Well, the 12 over 2 reduces to 6 over 1. The a to the 7th cancels with the a to the 7th, so we end up with 6 minus, now over here, well, the 10 and the 2, they cancel and become 5 over 1. And then these 7 a's down here cancel with 7 of the 9, so you're left with a to the 2nd power. So that leaves us with 5a to the 2nd power. And then lastly, right here, these 3 a's cancel with 3 of the 7 a's, so that these go away, leaving us with 4 down at the bottom. And then the 4 and the 2 cancel and give us 2 over 1. So what do we end up with? We end up with plus 2 in the numerator, a to the 4th in the denominator, and that is our solution. And the last one, just more of the same. They're just trying to scare the heck out of you. So you've got 15b to the 9th minus 15b to the 7th plus 9b to the 3rd all over 3b to the third. So what does that equal? So that means we're going to separate that into three separate problems. 15b to the ninth over 3b to the third minus then 15b to the seventh over 3b to the third plus then we've got 9b to the third over 3b to the third. And now we've got three problems that we need to simplify. 15 over 3 becomes 5 over 1. These three b's cancel with 3 of the 9, leaving us with 6 b's. So our problem becomes 5b to the sixth. And then right here, 15 and 3, they cancel. Becomes 5 and 1. These three b's cancel with 3 of the 7, leaving 4. So we end up with minus 5b to the fourth power. And then lastly, let's do it in blue. 9 and 3 becomes 3 and 1. These 3 cancel with these 3, and so we're left with plus 3. So there is our answer. Now I'm going pretty fast through all this. So if you need a little talking through on how I'm getting this, please give me a call or pause and rewind and watch it again, and you'll start to develop an understanding of this.